Welcome back to geometry. We are at section 8.3. We're going to learn about 30, 60, 90 right triangles. Over to the right, we have this drawing, and I want you to understand where this drawing comes from. Is if we were to start off with an equilateral triangle where all sides are the same, and let's just say for this equilateral triangle we said all sides were going to be 2x. And let's recall also that all equilateral triangles are also equiangular, so we could put 60 degrees inside all these angles. Okay, and so what they have done here is they've drawn an altitude from this angle, and it's going to create a 90-degree angle here, a 90-degree angle here. And if this angle is 60 and 60 and this angle is 90, that means this angle has to be 30 degrees and 30 degrees. So in a sense, all that they have done is just drawn down an altitude from this triangle, and so now we're looking at this triangle at the right. The other thing they did is if the base was 2x and we draw down this altitude and it creates a 90 degree angle, that means these two sides are the same, so we can call this x and x, which is what they have done here. Furthermore, if we looked at solving for h, and h is our height, we see that we have a right triangle, so let's make this right triangle on the right. We also have one on the left, but we'll just focus on this one in red. And what I can now say is that a squared plus b squared is equal to c squared. So let's let a be x. We have x squared. B will be h. And then c squared, the side opposite our 90-degree angle is always our hypotenuse. That'll be 2x and then squared. Alright, from there, let's solve for h. So we get x squared plus h squared equals 4x squared. Subtract x squared on each side, and I get h squared is equal to 3x squared. Now the reason why I'm solving for h here is that we will see after we solve for h that we have a theorem or a formula for 30, 60, 90 triangles. And this formula we'll see is going to be this diagram right here, and then we'll put this diagram in words so that we can further understand it more. Alright, so if we want to solve for h, let's take the square root of each side. Square root of each side. We get h equals. Rad 3 will not come out, it just stays rad 3. But if I take the square root, let's say of 3x squared, well that would be x times x. For every pair that I have, I'm allowed to pull out one of these, so the x comes out in front. So I get x rad 3. Okay, so we just found out that h is equal to x rad 3. Alright, well why is that important? We found h is equal to x rad 3. Well, the reason is that when we look at our formula, at how we solve for a 30, 60, 90 triangle, we see that we have x, we see that we have x rad 3, and we have 2x. So this x rad 3 is a result of us solving for the height or the h. Alright, we're going to mark this up more. The side opposite our 90-degree angle is always going to be our hypotenuse. So when you first start solving 30, 60, 90 triangles, it's usually a good idea to label each side so you know exactly what you're dealing with. The side opposite our 30-degree angle has to be our shortest leg or our shortest side. So I'm going to put SL for short leg. And then since we have a short leg, that means the side opposite our 60-degree angle is going to be longer or bigger than our short leg. So this is going to be called our long leg. Okay, but in a sense, our long leg is really our medium size side for this triangle. Our short leg is our shortest side, and then our hypotenuse is opposite our biggest angle, which is 90 degrees. Therefore, this will always be our longest side. Okay, but in terms of what we have for class, let's call the side opposite 30 degrees SL for short leg. Side opposite 60 degrees will be our long leg, or LL, and then the side opposite 90 degrees is always our hypotenuse. Okay, so if we were to put this drawing in words, it would say in any 30, 60, 90 triangle, the hypotenuse is always twice the short leg, and the long leg is always short leg times rad 3. And that's what we have right here with x and x rad 3 and 2x. Okay, let's keep moving. On these problems, for some reason they're out of order. This is going to be problem 1, and on problem 1, note that this is not a 30, 60, 90 triangle. So this is review from yesterday. Okay, but we're going to solve these problems in a similar approach, but remember that the rules change once we go to a 30, 60, 90 triangle. So with a 45, 45, 90 triangle, we have a leg and a leg, and we just say leg, leg because they're going to be the same length because they have the same angle measure opposite their length. So since these two angles are the same, their sides opposite have to be the same as well. Alright, next, you're moving from a leg to hypotenuse, and so you're going to be increasing in size, right? Because our hypotenuse has to be the longest side of any right triangle. So since we're going to increase, we're not going to divide, we're going to multiply, and then the rule here is that you multiply by rad 2. Again, please do not confuse the rules of a 30, 60, 90 triangle with the 45, 45, 90 triangle. So h is going to equal 5 rad 6 times rad 2. That gives me 5 rad 12. We have to break down rad 12. Rad 12 would break down to rad 4 times rad 3, which would give us 2 rad 3. And so that would give us 10 rad 3 for h. Alright, next problem. Now we have a 30, 60, 90 triangle, and we're actually going to solve this problem last because it's probably the most challenging one that we have out of the next 3 problems. Let's label this problem 2, and for some reason on your notes this did not make your notes, so let's fill this in. We have a 30, we have a 60, 90 degree angle, and you would be given that this is 14, and on problem 3 you would be told 90, you would be told 30 degrees and 60 degrees. Alright, now clearly this triangle is not drawn to scale because this angle looks more like 60 and this angle looks more like 30, but sometimes it will not be drawn to scale. Alright, and then we're going to tell you that this side is 8. Alright, so let's start off with problem number 2. Let's draw an arrow from 30 degrees, and we see that 14 has to be SL, which stands for short leg. The side opposite 60 degrees, this is going to be our long leg. And the side opposite our 90 degree angle, this is going to be our hypotenuse. Okay, so from there, if we want to move from a short leg to a long leg, we're going to increase in length. That means we're going to multiply. And the rule to go from short leg to long leg is it says long leg is always short leg times rad 3. So we multiply by rad 3. So the answer is going to be 14 rad 3 for our long leg. For the hypotenuse, we're going to go from short leg to hypotenuse. We're going to increase in size, multiply by 2. So we get 28. And on problem 3, we are given our 60 degree angle side first. So this is our long leg, again not drawn to scale. Short leg will be on this side, and then here's our hypotenuse. So to move from long leg to short leg, we're going to decrease in size. So that means we have to divide by rad 3. So we get 8 divided by rad 3. We're going to times this by rad 3 over rad 3. So we get 8 rad 3 over 3 is our short leg. Okay, and then to move from short leg to hypotenuse, we just multiply by 2 because we're going to increase. So multiply by 2. And if I take 8 rad 3 over 3 and I multiply all this by 2, my answer is just going to be 16 rad 3 divided by 3. That's our hypotenuse. One thing that we should note here is that we are not allowed to go from a long leg to hypotenuse. We can't do this. It's not allowed. Okay, so we have to find short leg first, and then once we find short leg, we can then fill out hypotenuse and long leg. Alright, we made it to our last problem. Problem number 4. We're given the hypotenuse, which is 4 rad 3. The side opposite 30 degrees will be our short leg. So x is our short leg, SL. To move from hypotenuse to short leg, we're going to decrease, divide by 2. So that would give me 4 rad 3 over 2, which would just give me x equals 2 rad 3. And then from short leg to long leg, we are going to increase in size, so we need to multiply by rad 3. So that would give me 2 rad 9, which would give me 6. Y is equal to 6. Alright, to the algebra review, let's cross multiply, FOIL. We get x squared plus x minus 6 is equal to 36. Minus 36 on both sides. X squared plus x minus 42 is equal to 0. X plus 7 times x minus 6 is equal to 0. X equals negative 7. X is equal to 6. Problem 2, we get 2x times x minus 1 equals 24. 2x squared minus 2x equals 24. 2x squared minus 2x minus 24 is equal to 0. Let's pull out a 2. And we get x minus 4 times x plus 3 is equal to 0. X equals 4. X equals negative 3. Alright, then on this problem we're going to get x squared minus 3x plus 2 is equal to 30. X squared minus 3x minus 28 is equal to 0. X minus 7. X plus 4 is equal to 0, which means x equals 7. X equals negative 4. Thanks for joining us. See you next time.